Lecture 1 of 5. Topic 5. Vector. Subtopic 5.1. Vector in 3 dimensions. Learning outcome. Students should be able to A. State the type of vector. B. Find the magnitude of the vector and unit vector. C. Perform addition, subtraction, and scalar multiplication of vector. Vector in 3 dimensions. A vector is a quantity having both magnitude and direction. In 3 dimensions, the Cartesian coordinate system use x, y, and z axis to locate a point. Their axes are mutually perpendicular to each other. From diagram, we can see that OX is perpendicular to OY and perpendicular to OZ. Any point P in space can be specified by an order triple of number A, B, C, where A, B, and C are the steps in the direction of x, y, and z axis respectively to B. The vector OP have initial point at the origin O and terminate point at P, A, B, C. We now take unit vector I, J, and K in the direction of x, y, and z axis respectively. Vector OP can be written as OP equal to AI plus BJ plus CK. Type of vector. Position vector. A vector that starts at the origin and terminates at any arbitrary point is called position vector. The position vector of A is the vector that starts from the origin and ends at A. We denote that vector OA is equal to A. Zero vector. Zero vector or no vector is a vector with zero magnitude and no direction and is denoted by 0. Parallel vector. Two vectors are parallel if they have the same direction or are in exactly opposite direction. Two vectors u and v are parallel if we can write down u is equal to alpha v, where the alpha is the real number. Perpendicular vector. Two vectors u and v are perpendicular if angle between them is 19 degrees. Note that vector AB we can write down as vector OB minus vector OA. Magnitude of a vector and unit vector. The unit vector of a vector u is the vector whose magnitude is 1 unit in the direction of u. If u is equal to AI plus BJ plus CK, then the magnitude of u is square root of A square plus B square plus C square. The unit vector of u is vector divided by its own magnitude. Example 1. Find the magnitude and unit vector of vector A is equal to 2i plus 2j plus k. Given the vector A is equal to 2i plus 2j plus k, if we compare with the general form of the vector u is equal to ai plus bj plus ck, then magnitude of u is equal to square root of a square plus b square plus c square. So for this case, our a is equal to 2, our b is equal to 2, and our c is equal to 1. So magnitude of a is equal to square root of 2 square plus 2 square plus 1 square. So it's equal to 3. Next, we know that unit vector is equal to vector divided by its own magnitude. So when we want to find the unit vector of A is equal to vector A divided by magnitude of A. So it's equal to 1 over 3 times 2i plus 2j plus k. Addition, subtraction, and scalar multiplication of vector. For any vector, A is equal to A1i plus A2j plus A3k, and B is equal to B1i plus B2j plus B3k, and for any scalar, alpha is the real number. So if you want to find the vector A plus vector B, we just add the same component. So where we get the result, vector A plus vector B is equal to A1 plus B1 for component I, then plus A2 plus B2 with component J, and A3 plus B3 for component K. We also use the same method for subtraction. So where the vector A minus vector B is equal to A1 minus B1 for component I plus A2 minus B2 for component J and A3 minus B3 for component K. Where the scalar multiplication with the vector is alpha times the vector A, so means that every component of ijk we need to multiply with scalar alpha. So we will get alpha A1 for component I plus alpha A2 for component J plus alpha A3 for component K. Example 2. If vector A is equal to 2i plus 3j plus k and vector B is equal to I plus 2j minus 2k. So find A, vector A plus vector B, vector B minus vector A, and C, 3 times vector A. So for the vector A plus vector B, so first we substitute the vector A and B into, and then we just simplify. So we know for the addition, we must add with the same component. So we will get is 3i plus 5j minus k. Then for the vector B minus A is equal to negative I minus j minus 3k. C 3 times vector A. So first we will substitute vector A inside, and then this 3 we need times every component for I, j, and k. So 3 times 2i we will get 6i, and then 3 times 3j we will get 9j, and 3 times k we will get 3k. So we will get the result is 6i plus 9j plus 3k.